So, welcome to the British Tunnelling Society evening lecture. I hope all of you have had a great day at the conference today. Those of you have been to the conference, and if you've just come in for the evening lecture, you're very welcome as well. So we have three fantastic projects to talk about, and this is all part of the celebration of the 50th anniversary of the ITA. So it's 50 years that's been going. There's a book that's been produced of 50 iconic projects in the world. There's a copy of it out there. So the three people are going to talk about the three UK projects within that book. So I'm really looking forward to that. British Tunnelling Society was a founding member of the ITA, and the first president was Sir Alan Muir-Wood. He was remained associated with the ITA until he passed away in 2019. So, and the ITA have recently had a couple of their secretariat have passed away, and I'd like to ask Martin Knights to come up to the stand just to pay tribute to those two people.
Thanks, John. Can you hear me at the back? Okay. Organisations are created by individuals that are instrumental in their formation and growth. So tonight, BTS wants to formally recognise and pay tribute to the lives of Claude Berenguer and Olivier Villon, respectively the former Secretary-General and also the former Executive Director of the International Tunnelling Association. And their contribution to ITA was immense. Many of you in this room might know them, particularly if you're participating in any of the ITA events. Now, just to put this in context as far as BTS is concerned, many BTS members volunteer to promote ITA's agenda, and many BTS members are engaged on international projects. And importantly, BTS is an influential society within the ITA, having had three former UK presidents of ITA, several vice presidents, and also EXCO members as well. Damien McGurr of Covey is now on the ITA EXCO, and Dan Garbett is our UK representative. And also, Donald Lamont was officially recognised by the ITA as a principal contributor to ITA's mission throughout his leadership of his working group. So the death of Claude in late August is particularly poignant for the ITA, coming as it does so soon after the death of the former ITA Executive Director, Olivier Villon, in late July. I was president of ITA during the time that Claude and handed over his role to Olivier. My wife and I both counted Claude and Olivier as good friends. Claude was born in 1942 and studied civil engineering, and in 1965 began his professional career at the Centre of Tunnelling Studies in Lyon. This was followed by a move to Paris, where he worked for 3 years with the Ministry of Economics and International Affairs. The ITA Secretariat was subsequently established in France, and Claude headed the Secretariat team as the Secretary-General. What I should just point out is there should be an overhead shown with photographs of both Olivier and Claude. So if that could be brought up, I'd be very grateful. Claude remained in that post for more than 30 years, and then in 2011, he continued his dedication to ITA as a driving force behind the creation of the Committee and Foundation for Education and Training, which has been organising ITA training courses all over the world for the last 15 years. Claude will be remembered as a fine diplomat, an expert administrator, and a tireless promoter of underground infrastructure. ITA President Arnold Dick said that Olivier Villon's dedication to the promotion and development of underground space had left an indelible mark on the community and beyond. Olivier's leadership and hard work played a very crucial role this year in the success of the largest ever gathering of the ITA at the World Tunnelling event in Shenzhen, China, in April of this year. Olivia's legacy will live on through the numerous projects and agendas that he championed. The BTS expresses its condolences, saying, Olivia's impact on the international tunnelling community is significant. Olivier enabled this important NGO to achieve great things. And Tris Thomas said in his current editorial of Tunnelling Journal that despite many robust encounters in negotiations over Tunnelling Journal's participation in World Tunnelling events, Olivier would be a hard act to follow. Born in 1962, Olivier was dedicated to public service, and he held several administrative positions with French and international societies, and local and national government and NGOs. He was managing director of Akriterie and was the editor of its European tunnelling newsletter. Olivier and Claude's guiding principle was that ITA, now in its 50th year, is a federation of its now 80 member nations, and they both work tirelessly to increase ITA's influence and the promotion of tunnelling throughout the world. During the coming months, Claude and Olivier will be remembered at ITA member nation events, such as this one tonight. And there'll be a special memorial at the World Tunnelling Congress in Stockholm next year in May. So ITA is not only indebted to the work of Claude and Olivier, but to all those that promote and volunteer and direct tunnelling societies around the world, either because it's for the good of the industry, our careers, or just making the world a better place using underground space. I'll miss them both, as will many in ITA and BTS. Thank you.
Thank you very much, Martin. So now we move on to the three iconic projects. It's normal for me to have biographical notes to introduce the speaker, but one, I don't have those notes. I don't have any. And two, I would hope most of you will know our three very well-known speakers in the industry. I certainly do. I've been lucky enough to work with all three of them. So I'm very much looking forward to hearing them talk. So first up is Alan Myers, who's going to talk about the iconic project, which is the Channel Tunnel.
Thank you very much, John. And thanks for having me here. And it's nice to see a lot of old friends and accomplices over the years. My brief today was to explain why the Channel Tunnel might be considered an iconic project for the ITA book. Well, it actually was voted by worldwide construction people as the project of the century, the 20th century. So what more can I say? But so I thought I would tell you a little bit about the history, things you might not know, some of the few of the difficulties we had, and finally a bit of the legacy behind the Channel Tunnel and what we learned from doing it. I think there's only one person I've seen in the audience who probably knows more than me, and that's Helen. So if you see her pulling her face, then I've got something wrong. The first person to decide he wanted a Channel Tunnel was Napoleon in 1800 or whatever, and he started scratching about in France trying to start a tunnel. But the first person who actually made a real start on it was a Colonel Beaumont in 1830 or something, and he planned to run horses through it. And he drove a tunnel 2 kilometers approximately using steel arches, maybe in the wrong direction, but I know Helen, I went into the tunnel with Helen at one stage before we blanked it off, so you can't actually get in there anymore. We crossed the path of the Beaumont Tunnel, and we concreted up the portals of it both so that you can no longer see it. And then there was somebody called Whittaker built a machine that we dug out the ground just east of Folkestone. It didn't get anywhere, actually. And that was in the 50s, I think. And then in 76, there was a fairly good attempt using a Nuttall machine that went about 1 kilometre. It proved to be a pain in the butt for those of us who had to carry on with it because it wasn't quite wide enough for what we wanted. It caused a restraint in our logistics, but we were told we had to use it. And the first, I told you, I mentioned a few incidents you won't know about. The first incident on the Channel Tunnel when we started again in 87, early 87, was 10 fire brigades suddenly arrived on the site because one of the train drivers going past saw this smoke coming out of what was used as the access tunnel in 1976 when we were burning out the old TBM. So yeah, that was an incident filled. I think we all nearly got arrested that day. But yes, so we started our work planning in 1986. A lot of it was done in Croydon because we couldn't get access to the sites. And we had a lot of coordinating to do with the French because obviously we had to meet up with them. We went out on site to start doing some trials and things in January 1987. The day that Kent was cut off by snow. And I remember sending half a dozen men and Frank Cardiff there to start digging an exploratory shaft. And at 4 o'clock, he rung up and started screaming down the phone that there was no segments to put in the hole he'd dug. And bearing in mind he was about 2 miles from the nearest road and it was about 8 foot of snow everywhere, I think he was just making the point that we were going to we were starting. We didn't actually start until I think it was the 1st of April when Royal Assent was finally signed up. And at that time, we had to carry out what I believe was one of the most difficult parts of the whole tunnel, because we had to start with an inclined access that would hold the 5 rail tracks that would go down into the Shakespeare underground development and link the surface to the tunnels. And it was 12.5 meters wide and 8.5 meters high. And it was in broken, shattered ground that had been blasted down when they built the railway. And when the tide came in and out, so did the water and the sand. And we had some sand layers that we had to go through. And we were using what you call sprayed concrete linings, which no one had used before. So that was a really interesting start to the project. It could have knocked the whole lot on the head at a very early stage. It was such a technically difficult to achieve. But we got through that, and we got into the lower chalk, and then it got a lot easier for us for a while. The underground development was basically to produce chambers for the 7 tunnel boring machines, and also to provide an access to take all of the materials down into the tunnels. All the spoil that came out used the original access from 1976. We put a big conveyor in there. We had bunkers underground, so when the rolling stock with the spoil came out of all the tunnels, they automatically tipped into bunkers, and that was then fed with chain conveyors to the belt conveyor that went all the way up the adits. And the adits were about 1 in 7, if I remember rightly. So they were quite steep adits. And all the spoil came out of that. 6 million cube of spoil came out of that on those belts. And I can't remember them holding us up. Remarkable achievement to keep those belts, well, that belt, there was only one, running throughout. I mentioned the TBMs. There was 2 service tunnels, as you know, one landward and one out to sea, and there was 4 main tunnels. The 2 main running tunnels were built by Markham with Mitsubishi input, and the other 4 tunnel boring machines, all 3 going landward, which was 7 kilometres landward to Folkestone and the terminus, and the marine service tunnel were built by Howdens in Glasgow. So we had a few trips up to Howdens. The main difficulties that we probably had, and before I leave the tunnel boring machines, and in case I forget, the big marine tunnel boring machines, we achieved 400 metres a week, week after week after week. And I was looking at the HS2 rates and things recently, and I don't think they quite achieved that. But anyway, it was a tremendous performance to get those sort of rates in those days. I've got a couple of slides, put a couple of slides up, but I didn't bring any slides because we didn't have any digital stuff. I've got loads of videos and standard photographs and slides and pictures from the old days, but no digital stuff. So apologies for that, but I don't think you need to know what the layout of the tunnels are. Probably most of you have been through there. Cross passages were every 375 metres. The key to the cross passages as we went along was to feed the tunnel boring machines, because we needed pumping stations, we need electrical substations, we needed all the things that support the tunnel boring machines to be put into the cross passages. And the cross passages had to be close enough to the tunnel boring machines to make sure that they could give that support. So there was a real challenge program-wise to make it all fit together. In fact, the logistics was one of the key issues. It took 2.5 hours towards the end to get to the face of the marine service tunnel because of the things that were in your way on the rolling stock. But we addressed the rolling stock issues by bringing in someone who just retired as chief engineer for the railways, Tim Green, and we gave him 1,000 men, because that's what it took to run the railways. We had the 3rd biggest railway in the country after what was then British Rail and London Underground. And everything was disciplined, everything was planned. We had control rooms with everything lit up, and which most of the things I'm talking about were new to us. We were learning. You take them for granted now because they've all been used around the world in similar situations. We had a main controller process that we were trained on, a few of us, that was very similar to the control room that Eurotunnel have now got. And when I said we were all trained, I remember one morning about 8 o'clock, the phone went, and I picked it up, and they said, "Can you identify yourself, please?" And I said, "Alan Myers." He said, "Right, you are main controller. I've just had a message from down in the underground development. There's been an electrical explosion. They've requested everybody is evacuated from the tunnels. Can you say yes or no, please?" yeah, we had to deal with things of that nature. I actually said, I'll be there in 3 minutes. In that 3 minutes, I wanted to find out who's in charge on the ground, what caused the incident, exactly where it is, and why they want to evacuate everybody. By the time I got there, they had the story straight. I was able to talk to the person on the ground, underground, at the time when the electrical explosion occurred, and we agreed that we could probably manage without evacuating 5,000 people, which would have caused as many problems as enough. So we had a very robust safety regime as well. And that's probably one of the legacy aspects of it. There was a step change in British industry safety-wise, as Donald would vouch for, Donald Lamont would vouch for. And that, again, is a very good legacy. I've got a few notes, excuse me, just to make sure I don't run out of things I was going to say before I do. One of the incidents that we had that didn't really get talked about much was in the crossover, that fella. And it's strange, that chamber looked absolutely enormous until the tunnel boring machine came in. And then the tunnel boring machine looked really small, and it was over 9 meters diameter. And the chamber didn't look quite as big. So when they came into the chamber, it sort of spoiled the image of it all. I remember taking one of the technical experts from around the world who used to come there, and it was 7 kilometers out from land to along the service tunnel to get to the crossover chamber, and the tunnel boring machine. Whilst we built that chamber, the marine service tunnel boring machine advanced another 7 kilometers, with all the cross passages associated with it, every 370 meters, etc., etc. And the chamber was built from just a small passage that we created out the side of the service tunnel. I took this Japanese expert into the tunnel, and he actually just said, you know, it's 160 meters long, this chamber. It was 22.5, that's a cricket field wide, 22.5 meters wide, and 18.5 meters high. And it had just been, the excavation of it with the primary lining had just been completed when I took this guy up, which is why I mentioned it. And he walked in and he was just awestruck. Wow. And he rattled on in Japanese about unbelievable the size of it. And when we were doing the crown of the tunnel, there was a sudden crack down both sides. And it was an area about the size of this room. And a crack appeared on both sides, and water started running out. And it came about because, not from the sea, it came about because there was an area or a volume of water just above the tunnel that the pressure had built up on the ground as we constructed the chamber. And it cracked down both sides. We were 7 kilometers out under the sea. And the release of the water was what was most important. So we immediately bolted it all up down both sides, and we installed water drainage everywhere. The whole system of water drainage to make sure that it wasn't possible for any more water pressure to build up. And I remember talking to the foreman, Tony Kelly, a couple of weeks afterwards, and I wanted to thank him and his men for sticking with it and getting stuck into the repairs that we had to put in place pretty rapid. And he looked at me and he squinted and he said, there was nowhere to go. We had to do it. There was no point in trying to run. So it was one of them things when, before we started, we had a risk assessment done, of the chamber. I'm waffling a little bit, but I'm sure you'll appreciate these stories rather than telling you the precise details. We had a 3-volume risk assessment done on the likelihood of an inundation from the sea into that crossover. And it said, the executive summary at the start of these big 3 volumes said there's a 16 million chance, 1 in 16 million chance of this occurring on similar crossover chambers built around the world in the future. And I thought, 1 in 16 million, and the whole lot and it actually dropped about 6 inches, 150 for the younger ones. The whole crown of the chamber, the size of this room. So that was a bit testing at the time, especially, as I say, when we had 5,000 people down there. And I think one of the legacies, if I move on to the legacies, concrete in that chamber, we wouldn't say invented, we put together 3 companies that enabled us to take materials in dry, and it was all batched down there. Everything went in on the rolling stock, obviously, and the batching was down there. And only in the last 5 years has that bringing together dry materials and a pump, swing and stetter, and Morehouse with the rolling stock, bringing all that together and mixing it is now seems to be the way of the world for buildings that are being built all around. Houses, that type of building, sorry. If you want any ready-mix now, you don't get a ready-mix truck, certainly not where I live. You get one of these machines that puts these 3 things together. And that started from down in the tunnel. And I'm sure that somebody who remembers it decided this was a good way of mixing concrete in the future. And I think that the other things that we actually achieved, but we didn't get any credit from, was, and I alluded to it earlier, we, in terms of constructing the tunnels, we weren't really behind program. In terms of constructing the tunnels, we weren't very far behind budget. The Joint Safety Executive that oversaw the whole lot, they had a major impact on our work and the way we had to do things, putting cooling pipes in everywhere and things of that nature, which was after the tunnel was completed. I've got a flashing light telling me I'm nearly finished. So what I'm going to say, because I didn't get a chance to talk about the fact that 11 people were killed, and I used to know the names and what their job was. But actually, I knew more than 11 people who were killed off-site. There was people who fell off the cliff and got stabbed in nightclubs and crashes in the motorway and things of that nature. Had heart attacks on holiday. But there was 11 people, and that's why I think we ended up with such a big step change, because they were in the early days. So, I'm looking at somebody, and there are 3 people here, and I'm going to ask them to give me a question in the questions and answers, so that I can say a bit more. Peter will ask me about the locos. Colin will ask me about Margaret Thatcher's input into the project. And I will sit down. Thank you very much.
Okay, so we'll take questions at the very end after all 3 speakers. So thank you, Alan. Great to hear from someone who was actually living and breathing that project. And Now Mike King will talk about Crossrail, the Queen Elizabeth line.
Good evening, everybody. Can you hear me? That's excellent. It means I don't have to crouch on these things. And now I've got to be honest. This evening, to me, is feeling a bit like a memory test for those of us that have come dressed as supply teachers. But let's see how we do. The thing is not working. IT? Oh, all right, here we go. Okay. No, I think the Channel Tunnel pretty much just about top trumps the Crossrail in terms of the gestation period for the project. But thinking back, there have been schemes for a cross-London link going back to Brunel's time, principally when he wanted to link up Paddington with his Farrington station as well. And then through the many decades, cross-London link of one form or another appeared in various documents until pretty much it started gaining a bit more momentum after the Second World War. But by 1989, we were producing documents that were talking about the Jubilee Line, which is now built, Crossrail, which is now built, and the Chelsea Hackney Line, which is not quite built yet and on hold as Crossrail 2. From that point onwards, I'm kind of referring to my CV from here because I came off the Channel Tunnel in 1990 and I started work straight away on the Crossrail project preparing the parliamentary plans. So we're doing parliamentary plans in 1990. By the mid-90s, we'd completed a full detailed design of the Crossrail route. I worked on the western section from Royal Oak Portal to Tottenham Court Road. That was fully designed, specified, contract documents ready, and then the government pulled the plug. Obviously, £2 billion was too much to pay for a railway in London at the time. The project then went on hold, and finally, again, it started coming to life again in the mid-2000s. So by about 2005, we were producing, we'd gone back a few design stages, but we were producing designs for a revised scheme. This time I was working on the western section. And then by 2008, the whole project got approval. 2009, I started working on it full time. And then the tunnelling work started in around about 2010. The majority of the tunnelling was finished by 2015, but there were a few bits and pieces of other works going on after that time. Now, at the time, the project was the largest project in Europe, with a route running from Reading in the west, all the way past Heathrow, picking up a spur from Heathrow, through the central city districts, Docklands area, and out to Shenfield in the northeast and Abbeywood in the southeast. The aim of the scheme, and it's achieved this, is increasing London's capacity, the railway capacity by about 10%, and relieving congestion at some of the major stations, particularly Paddington and Liverpool Street were highlighted. So it's relieving crowd congestion. Since the scheme's now open, it's brought about 1.5 million people within a 45-minute travelling time of the central business districts in the city. And it's believed that, again, since the project opened, 200,000 new jobs have been created close to the scheme. That's including office workers, new hotels have opened, there's even a new museum on the route, and food outlets as well. In fact, in 2023, 51% of the new office lets in London were within a 10-minute walk of Crossrail. Now, none of that information is the most important thing about this project, but no matter what anyone tells you, the most important thing about this project is that it was in tunnel through the central section. Now, the main route through the central section is there. You can see all of the different structures that were built, the main structures, stations, shafts, bifurcations, etc. And the only thing I'm going to point out on this slide is that for the main tunnel drives, Contract 300 was driving tunnels from Royal Oak Portal in the west to Farringdon. Contract 305 worked from Limo Shaft in the east, driving tunnels to Farringdon and out to Victoria Dock, but also the section from Stepney Green up to Pudding Mill Lane Portal. And Contract 310 was the main tunnel under the Thames. In terms of the geology, the tunnels were principally in London clay, in the western section, pretty much all the way from Royal Oak Portal to Fisher Street. And then from Fisher Street, moving east, we were dipping in and out of the Lambeth Group, Woolwich and Reading beds to most of us, even approaching and getting into the Thanet Sands in places as well. And as you move further out to the east, the Thames crossing went through various strata, but the majority of that contract 310, was in the chalk, in the water-bearing chalk. Now, I'm not going to have time to go through every structure on the project. I've got a few pictures. The rest of the presentation is pictures, hopefully to remind a few people of happy days. By the time we were working on the project in certainly 2005 and up to 2008, we were deleting shafts from the project, but there are still a number of major shafts on the scheme which are acting as plant rooms, ventilation adits, and access and adits points as well, particularly where the station spacing might be a little bit large. The other tunnel just worth a mention is the Connaught Tunnel, because that's slightly different from everything else we did on the scheme. Connaught Tunnel was pretty much a disused, dilapidated. It was too small. It was falling apart. It flooded on a regular basis. And on that scheme, it was brought up to modern railway standards through a combination of replacement and refurbishment works. If we look at the stations on the project, they pretty much came in sort of two flavours. The first flavour is large box structures, like the one there. That's actually Paddington, image of Paddington. And the other flavour was board SCL-supported ground, board tunnels for the platform tunnels, concourses, escalators, etc. But with slightly smaller boxes at the ends, housing ticket halls, plant rooms, and again, ventilation equipment, etc. So those big box structures constructed through a combination of diaphragm walling and piling, again with a mixture of top-down and bottom-up construction techniques, quite often constructed in very confined spaces with sensitive neighbours. Sometimes the sites we were working on there were actually no larger than the station footprint itself. So very, very difficult conditions. Also, a lot of these stations and shafts at some point in the contract might have had a TBM passing through them, so they had to be designed for that. And it also became a bit of a program issue in getting everything aligned between the different contractors to decide who's going first, who's going to be second, who's going to stand around for a little while the other contractor completes his work. The completed station boxes all have a slightly unique feel to them along the project, but they are generally structures that have tried to use natural light wherever possible. They're not the largest structures in the world, but by London standards, they're pretty impressive. The Canary Wharf station, for example, on the right-hand side with the garden in the top, the length of the Canary Wharf station is the same, or just slightly less than the height of the Shard structure. So it gives you an idea of the size of the excavations we were doing. For the board platform tunnels, now that the platform tunnels, the escalators, the concourse tunnels were all very, very similar size and shape, around about the 10-metre mark for the finished diameter. They were constructed with a sprayed concrete primary lining, waterproof membrane, and in most places a sprayed concrete secondary lining. Farringdon was the exception there, where Farringdon used sheet waterproof membrane and cast in situ secondary lining. All of the other platform tunnels generally had sprayed waterproof membrane. A couple of these, the stations that were in water-bearing grounds in the invert, had sheet membrane and a cast in situ invert. The primary lining on Crossrail was taken to be part of the permanent works. So it's taking some of the ground load that's developed in there before the secondary linings put in place. The secondary lining then shares the remainder of the ground load and the water pressure. This actually caused a few issues on Crossrail and some very, very difficult situations with the interfaces, because the client required the primary lining to have to be the design responsibility of his main designer. It was an engineering design project. But the contractor was essentially responsible for that lining during the construction process, supporting the ground, preventing ground movement, and for the safety of the works. So there was an issue about who has responsibility for what and when that changed. And that's bad enough in a simple round tunnel that's shown there. When you start dividing up into side drifts and having cross passages junctioning up with the tunnels as well, that responsibility matrix got very, very difficult. And for those of you in the audience that were involved in that, I'll take this opportunity to say thank you, and I hope your psychiatry bills weren't as much as mine. For those of you that weren't involved in that, don't ever, ever do it again. So the main station tunnels, generally we tried to work to recommendations in terms of excavation sizes that were recommended following the Heathrow collapse. So we were trying to work to about 30 metre squared face sizes and about 4.5 metres height in terms of unsupported face. So we ended up with top-heading bench invert type construction and pilot tunnels through various stations as well. The pilot tunnels were either spray concrete lining or segmental lining if through that station the TBM went first. Where the segmental lining was used in the pilot tunnel, the length of the rings was 1 metre to align with the excavation sequencing for the spray concrete linings. The finished board stations have a slightly more uniform identity across the whole project. They were meant to be to feel spacious. There's wide platforms. The cross passages are wide, and the concourses are wide as well. So the identity of the project was very much space. The length of the platforms is about twice the length of a standard London Underground platform. So hopefully some of you have been down there to appreciate it. A lot of work was put into using these curved corners. These curved corners here, certainly at the cross passages, but many other areas as well. Again, it was partly an architectural requirement, but it was there to help increase the feeling of the space within the project as well. There are other SCL structures on the project. These were either bifurcations, which is Stepney Green, where the line splits to the northeast and southeast of London, or they were crossovers, as there were at Fisher Street and Whitechapel. Again, there were multi-face excavations, top-heading bench invert, single side drifts, double side drifts, to achieve the finished product. And again, the lining systems were very much like the platform tunnels, sprayed concrete primary lining. Again, division of responsibility issues there. Waterproof membrane, generally sprayed. A couple of areas where we use sheet membrane in the invert, where there were potentially high water flows. And sprayed secondary linings. Some inverts where we use sheet membranes were cast in situ. Now, I don't know if this is true, but I do believe there was some sort of competition going on the project as to who could build the largest cavern. It just so happens that the last cavern built was about 100 mil bigger than the one we thought was going to be the largest cavern on the project. So perhaps someone can clarify that at the end of this conference. For the main tunnels, we used 8 TBMs. There were 6 EPB machines and 2 slurry machines. The slurry machines were used on the Thames tunnels. They were actually the first TBMs in the UK to have refuges fitted. They weren't used in Anglia on our project, thankfully. but they were designed to hold 20 people for up to 24 hours, probably pretty uncomfortable conditions, though I would imagine. Excluding delays, I think we were getting tunnel progress rates. It varied across the project, depending on all sorts of variables. But generally, average rates were between 10 and 18 rings per day. I believe the maximum, so that's 15 to 25 metres per day as an average. I believe the maximum advance rate achieved was about 95 metres in one day. So pretty impressive stuff when they got going. The tunnels and the stations were, we were working under some of the most expensive lawyers in the country, so we had to be careful with ground movements. On the station tunnels, with those massive concourses and platform tunnels, we used a large array of compensation grouting to keep the world up where it needs to belong. On the TBM board tunnels, the contractors generally work to a contract requirement of 1% ground loss. There was a few special control zones where we worked to between 0.5 and 0.75, depending on what was required. So we were generally controlling settlement at the face rather than relying too much on other protection works at the surface. I believe the typical range, we went over it a little bit on a couple of occasions, but typically the contractors were comfortably achieving between 0.25 and 0.5. Most of the time they were probably well under that, and certainly under the 0.25 on many occasions. The TBMs launched from shafts, relaunched through stations, etc. These were all fairly standard. Just a couple to note that were slightly different. At Royal Oak Portal, the TBM was erected about 600 to 800 metres away from the portal face, and this was to avoid any heavy lifts taking place very close to the mainline railway going into Paddington. The completed machine and the backup was then transported down to the portal face. And on contract 310, the Thames tunnels, they used the tension rod launching system, launch ring system. So basically tying the launch ring to the head wall in front of you and using tension to push the machine into the ground, which eliminates the need for temporary rings to shove the TBM off a shove frame. In terms of reception, again, lots of different receptions in adits and through head walls. The interesting ones to note on the project were at Farringdon, where driving from the west, the machines turned a sharp corner, much like we're looking at on the Channel Tunnel. We turned a sharp corner and stripped out what we could and buried the machines in the ground either side of Farringdon Station. The machines coming from the other direction were dismantled underground in purpose-built chambers at the end of the platform tunnel. The tunnel spoil was generally removed through conveyors, through the tunnels up to the surface. Obviously, the slurry machines, it was pumped out. and from the surface, it was either transported by barge or by rail. And about just over 98% of the material was reused on various schemes. Most of it went to Wallasey Island to create a bird sanctuary, but there were a few other local initiatives as well, filling up old landfill sites, etc. Segmental linings, I'm going to whip through the segmentals. We've all seen lots of segmental tunnels. They were supplied, manufactured on three main sites. That was at Old Oak Common was one site, Chatham in Kent was another site, and the Shea Murtar facility in Ireland supplied segments as well. They were all steel fibre reinforced, and there were a couple of local sections, particularly under the floating track slab, where we needed to have a little bit of reinforcement in the cages. 6.2 metre diameter running tunnels, 3 dowels between the rings, 2 bolts through the longitudinal joints, which were generally removed where they had ran a risk of coming loose and falling out and affecting operational railways. The tunnels had a left and a right ring on 2 of the contracts. And this was because we couldn't have the keys in the invert because the loads from the floating track slab pads was not compatible with a key being in place. So we had left and right rings, rolling the rings, but keeping the key above the axis. Now, I didn't actually check this fact, and it's just working from memory, and I may be wrong, but I do believe contract 310 didn't have any floating track slab and essentially used a universal ring system. Just some more images of the ring build there. There were many other structures, tunnels on the project, cross passages, diverted cable tunnels, ventilation alleys, etc. There was a combination of using SGI and sprayed concrete linings. Where we were breaking out of the main running tunnels, we had the what I think most people are familiar with now, which is the hybrid ring system. So an SGI frame with temporary segments that can be removed, top right on the screen, which can be removed, basically forming the permanent structure, or the majority of the permanent structure to support the opening. Contract 310, again, did things slightly different. They had a more extensive temporary works and used a reinforced concrete support system. Now, obviously, everything didn't go perfectly on the project, but we had some good days and bad days. Some of you will recognise those pictures of some of the things that occurred on the project. We hit a well at Tottenham Court Road, on the right-hand side there, a brick well. On the left-hand side there, we hit a raking pile in the docks, in the Docklands area. TBM hit that. But there were some worrying times that actually went very, very well. At Tottenham Court Road, top centre picture there, we weaved the TBM through the existing pile structure. We passed less than a foot away from the Northern Line platform tunnel on that particular section of the route. And the bottom centre picture there was one that always worried me in the early days. The red in the middle, the two red pictures there are the Northern Line, and we were constructing a massive shaft, ticket hall box, and enormous SCL tunnels above and below the Northern Line there. Again, the line remained operational, but everything went swimmingly. On the legacy side, now when I first joined the project, the word innovation was almost banned, but that soon changed, and Crossrail introduced the Innovate 18 program, which was a way of sharing ideas and knowledge across the project. All of the main contractors contributed seed funding to that. I imagine a lot of them paid for a lot of the work on their own projects as well. And ideas came in the first year of initiating the scheme. We had 800 ideas that came in, and 300 of those were funded. The Innovate 18 program morphed into the I3P scheme, and I think there were some representatives here today. I usually get this the wrong way round, but I3P is the Infrastructure Industry Innovation Program. On the other side of the legacy, we collated and disseminated large amounts of information, which is still available today through the Crossrail Learning Legacy website. We did this through best practice guides, case studies, and 6 volumes of papers that were published for the project. Now, this was a dangerous slide. I know you're all sitting there trying to look for your company name up there. So this was a memory test of the main companies I had some sort of involvement with on the project. Gives you an idea of the scale and complexity of the interfaces we were dealing with. If I've missed you out, I'm sorry. I would certainly straight away apologise to all the demolition contractors, the early works contractors, and the material suppliers, and I just didn't have space to fit all of those on. Now, I know this ain't the competition, but for those of you that have used Crossrail, I'll hope you'll believe that and agree with me that the stations are more impressive than the Channel Tunnel between Dover and Calais, and the trains far more impressive than anything you'll see on Tideway. Thank you very much.
Thank you, Mike. And our final speaker tonight is James Smith to talk about the Tideway project.
Evening all. I'm going to talk to you about Tideway, colloquially known as London Super Sewer. I'm conscious that probably many of you have been involved in the project itself, so I'll give you a brief history of the project, where we are now, and also I'm going to touch on some of the softer legacy commitments we've made as part of the project. So starting with the history. So we're looking at the rivers there, the lost rivers of London, probably the early 19th, 18th century. As the population of London grew, those rivers became open sewers. In the early 19th century, they became culverted in, so they almost became officially sewers themselves, but they all emptied out into the Thames. As the population continued to grow, as the flows continued to flow into the Thames, it culminated in the Great Stink of 1858, which many of you will probably know a little bit about. This resulted in the government of the time decamping to Oxford for 3 years and setting a young man by the name of Sir Joseph Bazalgette on the conquest to solve the problem. His solution is actually very simple. It's a number of interceptor sewers, effectively cutting off the rivers as they diverted down into the river itself. So he intercepted those flows and took them to a point in East London, now Beckton, which on a rising tide, where it outfalled into the river back in Beckton, it wouldn't reach the Houses of Parliament. So a very, very clever man indeed. So population in 1860, when he started to work, it was 2 million. As any good engineer, he decided some additional capacity, so he designed it for 4 million. That population was reached in 1920. We've passed 9 million now, and we're heading towards 16 million. So those overflows, which he built into his system, so effectively when the interceptors were beaten, they overflow into the river as that overflow. So we have a problem. That is the problem. In a typical year, we have 50 to 60 discharges into the River Thames, all along the tidal Thames, with a typical outfall of about 39 million tonnes of sewage. Not a nice thing. Now, the actual solution to this problem comes in 3 parts. So there's the sewage treatment works upgrades, which were all completed earlier in the 2010s. The Lee Tunnel, which was completed back in 2015, 2016. It's been operating since then. Why was the Lee Tunnel done early? That was because Abbey Mills is the single largest contributor to outfalls into the Thames itself. That's 40% of all the flows into the Thames as CSO discharges come from Abbey Mills. And the last element of the puzzle is Tideway, the Tideway Tunnel. So how does Tideway work? Well, effectively, it's a 25-kilometre tunnel. The majority is 7.2 metres in diameter internally. It falls from Acton in the west all the way to Stratford in the east. Collectively, with the Lee Tunnel, it has 1.6 million cubic metres of storage. This is a slice through the Victoria site, which many of you probably would have passed today on your way here. The gradient is 1 metre and just shy of 800, and it starts at sort of 30 metres deep in Acton and slowly falls down to sort of 66, 70 metres in Stratford. The Lee Tunnel itself actually finishes down at sort of the 80 metre mark, where there's the Tideway pumping station at Beckton, which then raises all the flows back up for treatment through the sewage treatment works at Beckton. That's the tunnel itself. So it's 23 sites. There are 18 direct interceptions of outfalls into the Thames. It influences a number of others, so effectively there are 57 outfalls in total across across the tidal Thames. The Tideway Tunnel and the Lee Tunnel effectively influence 37 of those outfalls, which results in a 95% reduction in discharges to the Thames. Very simply, in section, this is the tunnel. There were three main works contracts, West, Central and East, all tunnelling contracts, loosely aligned with the geology. So West was predominantly in the London clay, Central was in the sort of the shingles and the sands, and the Eastern contract was predominantly in the chalk. The Central contract was the only double drive shaft on the project, but there was also two rather significant connection sewers, one through Greenwich, which was a sort of 5 metre diameter connection from Greenwich pumping station, and also one in Wandsworth, which was a sort of 2 kilometres of 2 metre diameter connection sewer. So delivering those projects, or those tunnels, consortias, JVs, three main works contractor JVs, made up of BAM Nuttall, Morgan Sindall, Balfour BT, Fiover, Langerock, Costain, Voncy, and Bassy Soletanche. So the main works were undertaken through an option C target price NEC contract. And then connecting them all up was the systems integrator. So this was the sort of the control system, a fraction of the cost of the main works contracts, but very, very important indeed. And that's the stage we're going through at the moment, is the systems integration piece with Amy. So they were under an option E. They needed that flexibility because they needed to work with the main works contractors. So it seemed very much simpler to do that under an option E. There was a veneer over the top of an alliance agreement, which worked very well from a health and safety perspective and standardising designs, sharing best practices and lessons learnt. However, the incentives within that alliance soon became unachievable because of some of the issues that were encountered along the way, for example, COVID. Very brief timeline for the project. So planning permission, the DCO, was obtained in 2014. There was a year of enabling works, but before the main works contractors started in earnest in 2015. Tunnelling started in 2018, and primary tunnelling and secondary lining finished, as you can see there, 1 and 2 years ago now. So we are now in the midst of connecting up all those sites through the tunnel and activating those sites. So some of the pictures there. So yeah, as I said, that's some of the tunnelling activity which is now complete. And some of these, this is actually Abbey Mills pumping station. You can see Basil Jet's old sewage pumping station in the background there, the Cathedral of Sewage, as it's colloquially known. So this was back in March this year. This is effectively a large manhole cover being lifted into place on top of the shaft at Abbey Mills. So this is the connection between the Lee Tunnel and the Tideway Tunnel. This was a 1,200-ton lift, huge programme savings, because this was constructed just by the side of the manhole, or the shaft itself, and lifted into place. This effectively sealed the tunnel itself. And shortly afterwards, this is May of this year, the connection between, or the sort of the isolation between the Lee Tunnel and the Tideway Tunnel was removed to form a single tunnel system reaching from Beckton all the way back to Acton. So where are we now? So we are actually, the West and the East, the West and the Central contracts are nearing completion. It's turned into a bit of an architectural and landscaping project for those guys and girls. We're doing a lot of worksite testing. This is Princess Anne visiting the newly named Chelsea Quay, which is the Chelsea Embankment Foreshore site, as we knew it, back in the spring. So this is directly outside the Royal Hospital. So it's a very, very visible site. Similarly, this is the Blackfriars site just down the road here. This is the largest piece of new urban realm. So this is going to be opened probably later next year. But as you can see, it's still coming along very well. There's still some very integrated and difficult works to be undertaken under Blackfriars Bridge, so you can't see that on that picture. Similarly, further west, you're looking at, that's Falconbrook Pumping Station, so that's in Wandsworth. Again, they're looking at effectively opening those sites very soon. And Kirtling Street, which was our double drive site in the middle of Battersea, right next to Battersea Power Station. That was a huge logistics centre for the whole project, certainly from the central perspective, because it is driving east and west from that site. That now is basically a large concrete slab, and the property is slowly being returned to its previous owners. Three land packages have already been handed back to Battersea Power Station, who will be looking to develop it. Moving on to the west, this is the boat race earlier this year. For those of you who watched it, you probably wouldn't have noticed the fact that actually most people were standing on top of the public realm that we have built, and there's a shaft underneath there. On the far left-hand corner is one of the vent columns, although most people think it's a piece of public art, but it is actually one of the vent columns from the shaft itself. Acton, so this is where the tunnel starts. It's actually a Thames Water site. It's a storm tank site. Construction is substantially complete there now. That's some of the artwork that's been built or installed on the site itself, and that was opened by the Bazalgette family, descendants of Sir Joseph, last month. Moving on to King George's Park, this is in Wandsworth. This site was handed back to the public about 3 weeks ago. There was a bit of an unveiling there with the council. Again, you wouldn't actually recognise it as a sewage interception site, but that's what's happening underneath. The egg shape there is effectively the sort of a rough outline of the shaft itself. And then moving on to some of the works that are going on in the central contract. Nearly all the river sites are in the central contract, or the central part of the river. So a lot of cofferdam, a lot of marine works have been undertaken there. So we're at the process now of actually removing those cofferdams. You've got sort of before and after pictures there of where they were probably a couple of years ago and where they are now. So a lot of the marine works have been undertaken and completed across Chelsea, as we've seen before, Blackfriars, as we've seen before, with that Albert Embankment, which is another one of the sites directly in front of the sort of the MI6 building in Vauxhall. Some of the sites that aren't quite there yet. So Heathwall Pumping Station. Again, that's sort of right in the middle of the Vauxhall development area. Victoria, that's nearing completion. That's probably the nearest site to this one, and probably the best place to go and watch the fireworks, I would suggest, next year, because it's directly opposite the London Eye, and it is actually a very, very good piece of a public realm. And finally, in the central, that's Falconbrook there. Again, the pumping station, as you can see, the Thames Water pumping station in the middle, but the new public realm that's surrounding it. Moving on to East, well, construction's still ongoing in East. I'll start with Earl pumping station. So that opening is actually just to show where the last flume, the last piece of temporary works which were intercepting or protecting the workforce from the sewer flows, were removed earlier this year. And then on the left, Chambers Wharf, which was the drive site for the East contract. That had a large cofferdam constructed, increased the size of the site by 30 to 40%, just as a sort of the logistics yard to be able to do the tunnelling from there. Now they're in the process of removing that cofferdam, and I think circa 35,000 tonnes of material needs to be removed before that cofferdam is fully removed. Finally, in East, King Edward Memorial Park. So this is in Wapping. So again, you can see the marine works going on. So that's cofferdams coming out again. A lot of the sites now in East are in the sort of the mechanical electrical ICA testing phase. They were always sort of slightly tail end Charlie from the other two contracts. So they are very much the sort of critical path for completion of the whole project, but they're well on the way. Now, we didn't get there without a few key challenges. So just a few there. I'll pull out a couple really. I mean, there's the thing called COVID that had an impact on us. King Edward Memorial Park, there's the foreshore cofferdam stability. That's probably one of the few cases where actually when we got the delivery consent order development consent order, we had to actually amend it for a design change there. Originally, the Kemp site was an on-line shaft, but because of that instability, that ground instability, it had to be designed as an offline shaft to maintain program. But some of the other challenges we had, certainly the Greenwich TBM delivery was a bit of a challenge, only because it was hoped to deliver it in one go, in one piece, but in the end, because of the utilities and the weight, it had to be cut into 3 pieces and then reassembled on site. And then the last one, sort of the Abbey Mills bulkhead stability, we had to construct an additional some additional temporary works to secure that isolation between the 2 tunnels. So where are we? So underground construction is now complete. We're ongoing with connections to the existing sewage system. We're actually in the middle of testing as we speak. And the first new riverside spaces are open, as I've said already. We're still on track for completion in 2025, probably summertime in 2025. And the bottom left-hand corner there, that was a sea bass that was pulled out of the Channel Sea Creek. So that was the original outfall. So that was the Abbey Mills outfall, used to discharge into the Channel Sea Creek. Before we did the connection between the Lee Tunnel and the Tideway Tunnel, the EA went out and did a fish survey of the Channel Sea Creek, and they started pulling fish that size out of it. So that is the benefit of us not discharging sewage outfalls into the Thames. So that fish life is coming back. And this is a small tidal creek off the River Lee, so goodness knows what else is available in that Thames. So, hot off press, we've activated 3 sites. That's Barn Elms, King George's Park and Dormey Street, all in the west. They're all the smaller sites. And as of today, we've also activated the Acton site as well. So that is, flows are now being accepted into the tunnel from those sites. It's a sort of a gradual process because of the complicated control system that runs the tunnel itself and the operation of the tunnel. Each of the sites is activated, and then there's a pause just to make sure that there's the tunnel's working properly, but also there are no other issues regarding those sites and those activations. But it's great. It's a great place to be. That actually, after 10 years of construction, nearly, we are at the point of intercepting flows and cleaning up the River Thames. And just to prove it, so these are the event duration monitors. So these are on Thames Water's website. You can go onto Thames Water's website and look at them anytime you like. This was after the rain we had 3 weekends ago now. So as you can see, we had a lot of rain, And you can see the reds and the oranges all the way through the tidal Thames, apart from those 3 little green dots in the bottom left-hand corner. That's Dormey Street, King George's Park and Barn Elms. That was a huge, huge moment for the whole team when they saw that actually it's been worthwhile. Just on some of the softer side of Tideway, the challenge was to build a tunnel to prevent pollution, but Tideway, the company, always wanted to promote a change in the relationship between London and its river. So they made a number of commitments through the development consent order to do this. So they came in 5 themes. There was environment, health and safety, and well-being, economy, people, and place. The environment is reasonably straightforward and obvious that we're going to be doing a lot of environmental good to the River Thames. And health and safety I'll come on to in a minute, along with the people and economy. Place, again, 3 acres of new public realm has been developed. There's now more connectivity in the Thames Path within central London than there's ever been because of the sites where we have built our interceptions. So these commitments and these themes, there are 54 commitments throughout. They were mapped against the UN Sustainable Development Goals, and they were embedded in the main works contracts. One of the biggest pluses, I think, from the project, I mean, it was privately financed, but a lot of the money was raised through green bonds. 1.9 billion pounds worth of green bond or green issuance of money was borrowed by Tideway to deliver the project. These commitments and these themes underpin those green bonds. And the better we do from those commitments across the society, the better the interest rate is. So it's very, very, very important to the project. So looking at some of those themes, health, safety and well-being, the legacy, I'm sure many of you have been on the EPIC experience, the Employers Project Induction Centre. So this is a one-day, fully immersive experience for all staff who work on the project. I mean, I still remember well, it was 2 days back then, my trip to EPIC. It is a game changer, it really is. I mean, you do feel different after you walk out of that experience. 23,000 people have been through that, staff and external stakeholders. We've seen this being replicated elsewhere on new projects, and it's something the team are very, very proud of. Tideway is also a founding member of the mental health charity Mates in Mind. It was recognised that construction industry isn't a great place for mental health, and we've got 167 trained mental health first aiders across the project. We also invested in safer HGVs. We worked with TfL to have the world's first direct vision standards for HGVs, and a number of them were deployed across the project. River legacy. So this is people and economy. So boosting the river economy, really. So we had commitments within the DCO to use the river, but we did more by river. We focused on doing more by river. So more than 90% of spoil and materials was delivered by river, saving 344,000 HGV journeys, circa 17 million miles, and a saving of 24,500 tonnes of CO2. One barge is equivalent to 50 plus HGV lorries. So although very sceptical to start with, the whole of the main works really adopted this programme of using the river. We trebled the freight on on the River Thames with one project. To go along with that, the project invested and was a founding partner in the Thames Skills Academy. And that was for river apprentices. So again, to bring on the new generation of the marine operative. So 294 people have been through that program so far. And also looking into employ local and local river workers. Sorry. As you can see there, 67% from London, Essex and Kent, against a target of 30%, which was in the DCO. We've also got a boatmaster course, so that's a competency course that all boatmasters need to go through to prove competency for the River Thames, and without that competency, they don't get to work on the project. More in the people sphere, so again, encouraging women into construction. They had the first returners program outside banking. 12 women were placed in permanent roles. We had permanent placements for women in construction and secured 37 jobs. Worked with the PPE designers and providers to provide more inclusive PPE. This is now widespread, but it started with the Tideway, and again supporting local people. 25% of the workers came from the 14 London boroughs where we were affected. 1 in 29 apprentices across the project, employed over 1,000 unemployed people, and we worked with bringing people back in with convictions. So, in short, social value was huge. So, I mean, 20-odd million pounds was invested, but the social value study that was undertaken at the end of the programme identified actually that it almost doubled its net return. So a tunnel can have a bigger impact. And there we go.
Okay, thank you very much. We're running very tight on time, so I can probably take 1 or 2 questions only. They've got a few announcements, and then there's a presentation to celebrate these 3 iconic projects. So if anyone's got a burning desire to ask a question, please. Over there. Okay.
Oh, it's Colin. It's like an audience with Barry Humphries. I've got a question for Alan. Could you tell me what influence the Iron Lady had on the Channel Tunnel?
Thank you very much, Colin. Yeah, it gave me the opportunity to talk about the actual breakthroughs. It was mentioned that Crossrail copied us a bit. On the Marine Service Tunnel, we actually pushed the machine to the side, and the 2 big machines dived down when we connected. And the French, who had the more expensive machines, wanted to recover everything, whereas we decided to bury it all. It gave me the opportunity. Actually, Helen was there when Margaret Thatcher came, and it was a demonstration of the project and how long it took. When she came to officially open the tunnel, she wanted to take a piece of the rock that was cut, the very first piece, and we said to her, and Helen will verify it, and I said to her, if she came back in 3 years, I'll give her the most important piece, which was the last piece. And we started on the 4th of December 87 on the service tunnel. We drove 21.5 kilometres, and we finished with our connection to the French on the 1st of December in 1990. Unfortunately, Mrs. Thatcher wasn't there at that time. She lost her prime ministership a month before, so I took the very last piece of rock that was between us, had it encapsulated, broke it in 3, had it encapsulated, explaining what it was, and presented it to her, and it was on her desk probably till she died. Now, since she's died, I've been trying to track it down because I think it should be in a museum somewhere rather than lost forever. And I had a very nice letter to verify that it was the last piece from her in response to that. So yes, that's why I was asking for that question, Colin. I asked Peter for another question because I didn't have a chance to talk about the railway, the locomotives. The locomotives, we knew that we couldn't get there ventilation-wise with diesels, so we decided we would go with electric overhead catenary, pantographs, etc., which had never been done before. We didn't get too far before the water coming in was a lot more than what we expected, and that affected our TBMs as well because we didn't have a tailskin. We were building tight against the ground. So we came up with the idea of fingers above the TBMs to protect from broken rock coming in with the water. We had a lot of water for about 500 metres, 600 metres. But the problems that the water's made with the locomotives, which were Hunslet locomotives made in Leeds, as I say, it was the first time they'd used catenary or anything like that. Eventually, we realised that whilst we needed them to get 21 kilometres, we weren't going to get there unless we used some diesels. So we employed Shawmer diesels with them, alongside them. The Shawmer pushed out the heavy loads of spoil, and the electric overhead catenary took in all the segments and things. And we had to massively increase our ventilation because of the Shawmer diesels, which even more restricted the working space that went past all our cross passages and etc., and our pumping stations and things. So, yeah, thank you for those two very astute questions. I better shut up, John. You'll be cutting off my microphone.
Well, we're okay. No more red lights at the moment. Any more questions? No? Okay. Got a few BTS announcements and then we'll do the presentation. So go over here. Okay, so there's a little video here from Neil Hancox, who is the chair of the Tunnel Skills, and hopefully this plays okay.
Tunnel Skills was founded in 2008 to answer the industry's cry for a fully competent workforce. It was established with a group of consultants, contractors, labour providers and training organisations who are already affiliated with the British Tunnelling Society. Tunnel Skills is a national specialist training group. We look after the UK tunnelling industry's skills, competency, knowledge and training. Turing recent times, alongside the upkeep of existing industry qualifications, we've focused on closing the gap in establishing competency frameworks for all tunnelling occupations. Due to the increased use of conveyor systems, the latest qualification to be launched is the Overground Spoil Removal Conveyor Operations MVQ and Training course.
The benefits of it is, the conveyors are quite dangerous and there's been no training on conveyors before. It's basically, you can bring somebody in, they can be a conveyor operator and with the minimum training. But now the industry is stepping up, more training, more safety awareness and everything else. So it's a lot better for everybody, the companies and the guys.
I'd specifically like to thank the Tunnel Skills Working Group and the CITB Standards team for collaborating to launch this qualification.
Okay, I don't know if Neil's out there, but thank you, Neil. I've attended a couple of the Tunnel Skills meetings and they're very well attended from different people across the industry. So it's really good. What else we got? Okay, the book. Those of you who heard Sarah earlier, It's been a long journey. It's been 6 years in the making. I believe a book is going to turn up tomorrow morning, air freighted from the printers in Italy. Though most of you, if you've pre-ordered, we're looking at the back end of October for those, possibly early November. There's a few little I's and T's to cross and dot to get them into this country. But the air freighted advanced copy, all being well, will be here tomorrow. We have ordered additional books, so if you haven't ordered a book yet, you still can do that. You can do that via the website. So we haven't run out of books yet, but it's not a limitless supply. So if you haven't ordered one yet, I suggest you get in quick. All right, a few more announcements. So this is the 20th of November, Curry Glass Hydro Pump Storage, Exploratory Works. So a lot of discussions about that, even today, people talking about this project and what's coming up on that. So that is on the 20th of November, and that's with the BTS Concrete Society joint meeting as well. And then on Thursday, the 21st of November, it's the Harding Memorial Lecture by Charles Allen. Nice title there. What could possibly go wrong? Greenwashing and other things. I think only Charles could have come up with a title like that. And then Thursday, the 12th of December, the BTS meeting, HS2, lots S1 and S2, North Holt Tunnels, West Cross Passage, construction using artificial ground speakers, freezing, sorry, and speakers to be announced. Then next year, Thursday the 16th of January 2025, it's the Tunnel European Lyon Turin, speakers to be announced. The annual BTS Health and Safety course is open for bookings now, I believe. So that's on a Monday and Tuesday this year, the 18th and 19th of November. Excellent course with some industry experts talking at that on a variety of subjects. So yeah, I'd encourage you to, particularly some of the newer people into the industry, I'd encourage you to support that. This has been spoken about a lot today, Net Zero Tunnelling Group, and how the industry needs to reduce our carbon footprint down to that zero level that we're after. So the BTS have formed a group under Richard Southerden, and they've got a range of people from the industry, from different areas, clients, consultants, contractors, suppliers, to come up with some unified guidance to show us the way, our industry, to reduce our carbon footprint. All right, another one here, Thursday the 7th of November. So this is the Young BTS AGM, and then their meeting, Overcoming Challenges in Horizontal Direction Drilling, a geotechnical engineer's perspective. And that's from GCG. And then their annual conference, Young Members BTS Conference. And from what I've been hearing today, very innovative, coming up with different ways of doing things in terms of presenting the conference. And it's great to see that. So that is on Friday, the 29th of November, from 8:30 till 5 o'clock. And that's at the Arab offices in Charlotte Street. And also another Young Members initiative. This is St. Barbara's Day pub quiz on Thursday, the 5th of December. It's the first annual quiz. So there you go, a bit more innovation from the Young Members. And the trophy is provided by Herring Connection. So that's at 6 o'clock on Thursday the 5th, and it's in the ICE bar. All right, final slide is the book. Mentioned that a few times, I think. So, yeah. I haven't got enough time to tell you the journey. It's a story in itself, putting that book together and the way it's developed. But the subcommittee led by Ken Spivey, I just take my hat off to them, how they've managed to... Actually, I'm a member, so... but, Yeah, it's been a long journey, and I hope all of you who bought the book agree that it was worth the effort in the end. Okay, so that's the end of the slides. I'd like to now ask Damien McGurr up on the stage, please. Damien. You want to say a few words?
So I'm Damien McGarrett, past chair of the BTS, but also currently representing BTS in ITA on the executive committee as an executive council member. And I think it's great that these three projects have made it through to the ITA's 50th anniversary book, and it's great that we can reward them and present them here back in the UK this evening. So it's thanks to the speakers for reminiscing about the history of the projects, and I'd like to just present the certificates for their membership in that book to them this evening. So, thank you.
Okay. So I think we're going to go one side and then the other. All right, so first is Alan Myers for the Channel Tunnel. And second up is Mike King for Crossrail. Okay, James, your turn. Okay, that concludes the evening. Thanks everyone, and I think there's some refreshments.